Who should watch this lecture? I would say those who are new for this, those who are beginner for this. So those should watch. And people who are taking it as a revision, then this is for those people. Now in this we will explore what is a universal set, what is Venn diagrams, and what is a operation on sets. All this will be covered in this PPT. One by one, we will explore. In depth, we will understand it. Let's start. Now, our objectives, learning objectives in this is what? Is to, our purpose in this is to understand universal sets, Venn diagrams, operations and sets. These are topics that will be discussed with you. Now with universal set we are starting. Here is set. Universal set is a set. Here we are saying universal set. Here in this you can see there is a word which is a set. It is added with this universal word. Now we can confidently say that yes, universal set is a set because set word is added with the universal word. That's why we are saying that universal set is a set. A set that contains all sets in a given context is called the universal set. If a set is containing all sets will be universal, which means very big. This is a big set which is containing all sets will be universal set. This is a simple definition of a universal set. That's it. Universal set, it is a set which will be containing all those sets which will be in context. It is denoted by U. Universal set in mathematics, it will be denoted by U. Whenever we are representing U letter, we can say that this U is a universal set. Clear? No. Example, if A, this is a set, A is a set. In this set we have 1, 2, 3, 3 elements. No. Other set, in other set we have 4 elements, 2, 4, 5, 6. Okay. Again, third set, 1, 3, 5, 7. 3 set, we got 3 set. Then universal set of these sets would be what? Would be, so would be what? 1, 2, 3, 4, 5, 6, 7. This would be universal. Here 1, 2, 3, 4, 5, 6. Remember, repetitive same number we will not take, same elements we will not take in universal set. This will be universal set is a unique. It is a unique. It is not a repetition of elements. No, this is a unique set. Universal set will take unique elements, not common elements. Clear? So universal set of these sets are what? Is a universal. This is a universal set of these sets. This universal set is containing all these sets. This was a definition of a universal set. Okay, we can say okay. Example, here with graph, let's visualize it. The set of all points, all these points in xy plane is the universal set. Yes, on this plane, in this coordinate we have two points. In this coordinates we have 4 points. In this coordinate quadrant. In this quadrant we have three elements. In this quadrant we have three elements. But on this plane we have all these elements. So all these elements will be universal. This was visualization of a universal set. A collection of all points on a plane. A collection of all these points on a plane is a set, is a universal set. Now, sets containing natural numbers, then n is the universal set. If a set is containing natural numbers, will be natural universal set. Now next we have intervals on a real number. Intervals on a real number. The set R of real numbers is taken as the universal set. Here we are starting from -5 and here before the 6. This is what universal set. Now we have understood what is universal set. Universal set is a set which will contain all other sets. Then it will form new set which will be universal set. Now we are on the discussion of Venn diagrams. Venn diagrams. Sometimes pictures are very useful in our thinking. For visualization, pictures will be useful. We can also understand anything through picture, and this is where we are going to understand sets through pictures. It will be more this Venn diagram will give you more clarity. Whatever we have discussed will be discussed with this Venn diagram so that we can get clarity. Okay. Now here Venn diagrams are a tool to study relationship between sets. Here we have Venn diagram, not only diagram. Venn diagram are a tool. It is a tool to study relationship between sets. Between two sets, between three sets. What is a relationship? To know what is the relationship between sets through Venn diagram we try to know. So here we got a diagram, Venn diagram. In a Venn diagram, the universal set U, this complete is the universal set. This complete whole is a universal set. U is represented by points within a rectangle. This complete is in inversion. In this, a lot of sets can come. If this is happening, it means this universal set is containing all those sets. A set is a 2. In this set can come other sets. Here we have other set. This is a other set. It was already set. Now we got another set. This is another set, which is a diagram of this is what circle. Its subsets are represented by points in closed curve, usually circles. This is a subset. We are using this circle because of this is a subset of this rectangle. That's why we are using this circle rather than using rectangle. We are using this so that we can say that this set that we took is in universal set will be what? Subset. Now next we have again one more set. Here you can see. Can we say that this universal set has two sets? This one, this two. These two sets are what? Subsets of this universal set. Uses overlapping circles to show how things are alike and different. This gap, this shape is what? It is showing common elements. Whatever elements will come in this will be common, because this space is of this circle, this space is also of this circle. So this is common for these two sets. Okay, now examples in natural numbers from 1 to 30. Here multiples of 3, 3 ones are 3, 3 2 just 6, all these natural numbers 1 to 30, 1 to 30. So of course we will take 10 numbers here, 1 2 3 4 5 6 natural numbers. It is talking about natural numbers. 3 27 30. Here multiples of 5, 5 5, okay, till the 25. 5 1s are 5, 5 2s are 10, 5 4s are 20, 5 5s are 25, 5 5s are 25. So in this set we have how much? 10 elements, and in this set we have how much? Total we have 6 elements, and in this we have total how much? 2 to 4, 2 to 4. In this we have 10 elements, in this we have 6 elements. But here 15 30 is coming in this. Why not in this? Because 50 is 4 also this set, 50 is also 4 this, that's why 50 is also a table of a 3, and 50 is also a table of a 5. 5 3 is a 15, 3 5 is a 15, 3 8 is a 10, 5 6 is a 30. So this 30 is also coming in the table of a 3, 30 is also coming in the table of a 5, 30 is for both sets. That's why whatever will be common will be entered here, and this will show, these elements will show that I am common for this both. So we here understood what is common elements. With the help of these common elements, you will be able to understand about intersection. Let me move. Yes, so here 15 30 and this. So remember, let's visualize it in details. Here whales and fish have air, live earth, breathe air, live in water, have, all these are sets. This is a collection of whales. So this will be common and this will be uncommon. This is also elements of this, this is also elements of this. Here if a set A is a subset, set A is a subset of a set B, then the circle representing A is drawn inside this circle representing B. Okay, here we have this. Here it is saying that A is a subset of a B. This is what a circle is saying. A circle is saying that I am subset of a B. Here if A and B are not equal but they have some common elements, then to represent A and B we draw two intersecting circle. Intersecting circle we do. If both are not unequal, then both sets are not unequal, then we say what? Intersecting circles. Intersecting circles. Here you can see it is telling you that there are common things. There are common things. Both are not equal. See, if A and B have not any common element, not common, this, if both sets do not have common elements, in this case, then to represent A and B we draw two non-intersecting, just this circle and this circle, without any intersecting circle. Here you can see. there is no intersecting circle, because it is telling you that we don't have common elements. This is telling you that we have common elements, and this is telling you that a this whole A is a subset of B. Now next, operations on sets. Operations on sets. We have understood what is a universal set, what is a Venn diagrams. Now we are understanding about operations on sets. We have learned how to perform. We have learned how to perform the operations of addition, subtraction, multiplication, and division on numbers. We know how to use these operations. Each one of these operations was performed on a pair of numbers to get another number. Let's see with example 3 plus 15. Here plus, this is addition, which is operations, which is operator. Here we are adding. By adding we are getting 18. We are getting 18 by adding 3 plus 15. So this is addition operation. Now here this 3 multiple 15 is a what? Multiplication operator. Operations on set. We came to the main point about operations on sets. Here union of sets. This is an operator. Union of sets. Union of sets. Then intersection of sets. Then difference of sets. Then complement of sets. Complement of sets. Let's understand all this one by one without any barrier. Let's start. Union of sets. In this you will observe that we are not taking common things, just we are taking unique elements, not common elements. Here the union of A and B set is the set which consists. Remember, we will have already two sets, but apart from this set, one set will be formed which will be containing unique elements from two sets which is given. So the union of A and B is the set which consists of all the elements of A and all the elements of B, the common element being taken only once, not two times. Let's see this symbol. This not completely you, but it will look like this, is used to denote the union. Symbolically, we write A union B. A union B. Here we are saying that we have unique elements in other. We have unique elements and usually read as A union B. Thus, A union B, it can be written as set builder form. X such that X belongs to A or X belongs to B. Whatever will be X elements will belong also A, will belong to also B. For example, we are taking 4 as X, then this will be also in A, and this will be also in B. This is what we are saying. Example, we have one set in this 1 2 3, then 1 3 5 7 9. No, so union of A and B would be what? 1 2 3, then 5 7 9, 1 2 3 5 7 9. So 1 3, here again it is coming, so we will ignore it. Only one time we will write this common elements. So can we say that 1 2 3 5 7 9? Here we are saying this x is belonging to this a, and this x is belonging to y b, and this 1 3 1 3 and 1 3. So x belongs to a union b. Can be said x belongs to a or x belongs to b. Both are correct. 5 5. So x does not belong to a union b, because in this we don't have a 5. X does not belong to a. In the attached figure, this shaded part represents a union b. This complete. We will take also common, but not many times, only one time. All this will be union. U plus u. This a plus b. We are taking what? U a plus b, but not repeating element. So here we are understanding operators on sets. So here a plus b is a union. A plus b union. Now a subset a subset a is a subset of a union b, and b will be also a subset of a union b, because here we have a, so in this also we have a, that's why a is a subset of, because this is a part of this union. The b is also part of this, that's why we can say this is a proper subset of this. This is a yes subset of this. This b is also proper subset of this. Now with example let's understand this. Here we have two sets. Union of this would be, you know, okay, we are saying x is a subset, so we are saying that this is a piece of this. No, this is a piece of this. Of course we can see all the elements of a is in this, of course, that's why we are saying. And same with here, all these elements are in this, that's why we are saying this a b is a subset of this. And 1 3 5 7 9. Okay, this is done. If a and b are two sets, if a and b are two sets, a and b, okay, are two sets such that a is a subset of a b, then a is a union. A union b will be equal to b. Wow, two sets, then a is, here we are not saying that a is a proper, no, both are equal, that is what we are saying. In this case you can see a and this here b. So here what is happening, this and this both are equal, that's why we are saying this is equal to this, this is equal to this. If b is a subset of a, a is a subset of b, and this is also subset of this, both are equal. Properties: a union b, b union a. What's the difference? Both are same, both are same. Here we are adding a plus b is equal to b plus a. So commutative law, yes, we know. A union b, then again union c, same. A union b union c, both will be same. This is associative law. Okay, next examples. Okay, this is set, this b set, union, this is three sets. Here union of a and b would be what? 1 2 3 6, 1 2 3 6. This would be union of a and b here. Okay, okay, now what about this union c? In that case, we will get what? 1, 2, 3, 1, 2, 3, 4, 6, 1, 2, 3, 4, 6, 1, 2, 3, 4, 6. Here, 1, 2, 3, hold on, 1, 2, 3, 4, 6. Now we can say this is equal to, you can understand it, this is for you. Now here we are saying a subset is a union, this is this plus this is equal to A. Yes, because we have empty, that's why there is no element, that's why this will be equal to this will be equal to set A, and this is also equal to union this phi, because we don't have elements in this. Here we have only a set, that's why this will be known as law of identity elements. Here we are taking two sets which are same. In a set there are four elements, let's say there are four elements in a same this set we are taking. So here we are saying A union A, of course A plus A will give us A again. For example 1, 2, 3, 4. Then union of this, what we want? We will not take again 4, 2, 3, 1. Only same unique elements 1, 2, 3, 4, which is coming again subset, not only set. So this will be equal to this, and independent universal union A is equal to U, because A is a set and universal is a big set which will contain A also, A set also. That's why this will be equal to this, and this is just opposite of this. Both will be equally. Law of U. Ready for concept. Right now there is a one question which is in front of you. Let's answer it together. Question: if a set in a set A x such that x belongs, no, x is equal to 2n plus 1, and n is a what? N is not natural number, n is a number, n belongs to z. This is what? Integer number. So here first of all 0, then we will get 1, and B 1, then 2, then 3, same opposite of this we will get. Next we have B is equal to x such that x is equal to 2n and n. Suppose 2, then 3, 2, then 4, then 6, then 8, like that we will get. Then find A union B. This is infinite. Here we are getting like that, or integer. This is even integer. This was for you. Intersection of sets. Here we will take common elements for set. This intersection of two sets A and B is the set. This is another set. Is the set of all those elements which belongs to both A and B. There will be two or more elements which will belong to also A set, also B set, because here we are taking A common elements. If this is happening, so this type of a set will be intersection of a set. This symbol is used to represent intersection, which means common elements. The symbol intersection is used to denote the intersection. Symbolically, we write symbolically we write A union B is equal X, such that X belongs to A and X belongs to B. Here what are we saying? Whatever we are taking number as a X will belong to A, also will belong to B. Now in this case, what is happening? In the attached figure, in this figure, this field area is a intersection. This field area is a common element. So this A set, then this common intersection, then B. Example: if A, this is set, okay, with example we are understanding. In this, what is the common elements? What are common elements in this both sets? 1, also here 1, 2, not here, 3, yes, 5. So 1, 3, 5. These are elements which are in both sets. So 1, 3, 5 will be intersection. 1, 3, 5 will be common elements. We can say that A intersection B is equal to 1, 3, 5. This is what common elements between these two sets. This one, this another. 1, 1, 1. So here 1, 3, 5 came here. This is where we enter common elements. It is evident from the definition that A intersection B will be proper subset of A. And A is an intersection. A intersection B is a subset of B. It is very theory. Here we have 1, 3, 5, then 1, 2, 5. Intersection, what do we got? 1, 1, 1, 1. So can we say that 1 A, then intersection B is 1? It is a subset. Yes, it is a subset of A. Yes, till here we are clear. Here we can see A intersection of this and this will get what? We will get what? 1. So 1 is a subset of this. 1 is a subset of this. Now next, A intersection B is how much? 1. Now we are saying 1 is a subset of this. Yes, it is subset. 1 is what? Subset of this. This is what we saw in this. We are saying intersection would be subset of one set of a second set. This is what we are saying with the evident. Now can we move towards this slide? Okay, we are clear with this. If A and B are two sets, then A intersection B is equal to A. Okay. If A is a subset of B, also A intersection B is equal to B. In that case, what is happening? If B is a subset of A, B is a subset of A. What is happening here? We have to this, okay. Intersection of this would be what? 1, 3. 1, 3. This is the intersection. And here we are saying that this is equal to A. This is what we are saying. Can we say that this is equal to this? No. 1, 3 is a subset of this. Yes, this is what we are saying. This Okay, clear. If A and B are two sets such that A intersection B is a 5. Okay, so here there is a no common elements because empty, which means no common element. Then A and B are called disjoint sets, which means no common elements. The disjoint set is equal to no common elements. 2, 4, 6 set, 1, 3, 5, 7. And both sets there is no common element, and this will be disjoint set. In this we can say A intersection B is nothing or phi or empty set. Now properties, let's see. We know, okay, we know, yeah, same. This is a for you. This is for you. Next question on intersection. If A is equal to X such that X is 2A, okay, 2, 1, 2, then 4, no, 2, 4, 6. These are what? These are even numbers, even integer numbers. And in this case, we are getting what? 3 multiple 1, 3 2 is 6, then 3 3 is 9. This is a table of a 3. And then what is happening? 3 3 is 9, 3 3 is 12. Also, we are getting what a prime number or also even number. So intersection would be 6. Yes, 6. So whatever are even numbers in this will be intersection of this. Here you can see, here we are getting these prime numbers, even numbers, not prime numbers, even numbers. And here we are getting 3 6 9. So here 6 is intersection of this and this is a 6, and there are more infinity. In this case we are getting 606. 6 is also what? 6 is in both the sets. This is the difference of sets, which means subtraction of sets. This is very easy, I can say easily. We will subtract a set from another. Let's see. The difference of a sets A and B in this A and B, the difference of the sets A and B in this order is this set of elements which belongs to A but not B. Here we will be subtracting A from B, not B from A. This will be also done, but right now we are subtracting A from B. Symbolically, we write A. Here we are saying A belongs to B. Symbolically, we can write it to represent difference of a set. Like we are subtracting A from B. Then whatever will be subtracted elements which are in from this, and whatever left in this will be written as a difference of a sets and read as a minus b. Okay, it is read as A minus B. Here we are getting minus. This shaded portion represents the difference of the two sets. This is shaded. Here we subtracted this much and we got this much. The sets A minus B, A intersection B and B minus A are mutually disjoint sets. The intersection of any of these two sets is the null set as shown. Example, let's understand with this A in this set and in this set 1 2 4 and here 1 3 5 or 1 3 6. Here we have only one common elements which is intersection. Now then A minus B. Here what is the common? Here 1. This will go. 1 will go. Intersection will go. And whatever is left in this will be difference of this both the sets. So 2 4 is the answer for this question here. 2 4 2 4 2 4 is the answer. Now next, here 2 4 is not an intersection. A intersection B will give what? 1. B minus A, we are subtracting this from here. So from here we are starting this from here. So whatever will be gone, whatever will go from this, and whatever will left here will be difference of B minus A. So here minus. So here we go to 3 comma 6 for equation 1 from equation. Okay, now again question, let A okay, here we have 2 1 2 3 4 5 6, then be 2 4 6 8. So here we have common elements are what? 2 4 6. Yes, these are common elements. So A intersection B would be what? 2 4 6. Here question is saying subtract A from B and subtract B from A. Let's subtract. So here this one, okay, 2 4 6 will go from here. So 1 2 3 is the difference, is the answer for this. A minus B will be 1 2 3 and B minus A, here what will be? So here will be 2 6 2 6. So 4 8 for this 1 3 5. Yes, belongs to A but not to B. Yes, and here whatever will be left in this will not belong to A. Complement of a set, is it hard? Is it harder to understand it? Let's see. Complement of a set. Let universal be the universal set and A subset of universal. Then the complement of A is the set of all elements of universal which are not the element of A. This is a theory. Symbolically, we write A to denote the complement. Yes, now I remember. Just again, just opposite you can say. A above dash we symbolically we write A, then this line to denote the complement of A, just opposite of this A with respect to U, with respect to universal. Thus A is what we are saying, X is such that X belongs to U also, but X does not belong to A. So here we are saying X does not belong to A. With example, let's say this is complement is equal to complement of A is equal to U minus A. Here we have this A complement. We will announce it A complement. Complement of A, complement of this would be this. Complement of this would be this A. This shaded portion represents the complement of a set A. This is shaded complement of this. This is complement of this. A with respect to U in below figure. The complement of the union of two sets is the intersection. Is the intersection of their complements. De Morgan's law. Complement of this union is equal to complement of A intersection complement B. This is very hard. Complement. This red is a complement of this two sets. This two circles is a complement of this. This is complement. It is not over. There are a lot of things. You can see here. I liked it. This isn't. There are 450. Wow. That's all in this